Hello everyone, so today we are going to talk about the expansion of polynomials, the binomial formula and binomial theorems. So first is we have some binomial formulas that are known, such as a plus b raised to 1 is just equal to a plus b. Then a plus b quantity raised to 2 is equal to this. So these formulas are quite popular or quite common to us, and we also memorize and familiarize this equation. But what if we have given this kind of equation, or this, or this, or this? How can we solve this kind of equation if our professor ask us to expand these polynomials or this equation? How are we going to do that? So that's why we have this binomial theorem. Then you are also panic. How does it work? Why does it looks like this? So that binomial formula, how does it works? So if you are given that quantity a plus b is raised to a power such as n, how can we expand that polynomial if it is raised in a higher number such as 7, 10, 12, 14, and so on? So the first step is that the first term is a raised to n, and the second term is the power times the first term, which is raised to n minus 1 times the second term. And the third step is that the exponents, or we can see that the exponents of a, or the first term, decrease by 1. That's why we have here n minus 1 from term to term. So each term, the exponent of the first term will decrease by 1. And the exponents of b will increase by 1 from term to term. So this is the second term. And then the third term, for that, the exponent of b will be 2. Since here the exponent is 1, so we increase it by 1. So 1 plus 1 is simply 2. And lastly, for the coefficient of the next term, multiply the exponent of a in the term and divide by the exponent of b plus 1. So to understand it further, we will have our example. So for example number 1, quantity 3x plus 4y, quantity raised to 7. So we're going to expand this polynomial. So we're just going to follow the instruction that we have discussed with this. So we're going to follow this process, and I hope that you fully understand and you can apply it with our example. So the first term here will be, so it is said that the first term to expand this polynomial is its first term raised to the power, to this power, times the second term raised to 0, because as it has been discussed, the first first term will decrease by 1 as by will decrease by 1 term by term, and the second term will increase by 1 by through the equation term by term. So that's why we have this first term as the first term of this polynomial raised to the exponent, and 4y raised to 0. So plus the exponent times the first term raised to the exponent minus 1, because it will decrease by 1. So that's why it's 6. Then times the second term raised to 1, because it will increase by 1. So the next um the um the next term will be determined by multiplying the exponent of the first term to the to this term, or to this number, to this number. So 7 times 6, which is equal to 42. Then it is said to the process that we are going to divide it by the exponent of the second term plus 1. So 1, the exponent of this is 1. So you have to add it by 1, so it will become 2. So 42 divided 2 will be 21. That's why we have here 21. Then again times the first term raised to 5, because we have to decrease this exponent by 1, and then the second term raised to 2, because it will increase by 1. So we have to, from the third term, you are going to repeat the process again, just like how we find the third term. So here, so we have 21 times 5 times the exponent of the first term, which is equal to 105, divide it by the exponent of the second term plus 1. So divide it by 3. So that's why you have 35. So you're just going to repeat the process until you will arrive with the last term, in which the first term in this polynomial, the exponent of it will be 0, and the last term, or the second term of this polynomial, will be raised in the original exponent of this polynomial. So you have to take note also that when we expand a polynomial with a given exponent, the number of terms that you will arrive to expand it will be the exponent plus 1. So meaning, if we have 7 here as exponent, the number of our terms that we must get will be 7 plus 1. So this term must be equal to 8. So we try to check it. So we count here 1, 2, 3, 4, 5, 6, 7, and 8. So by that, you can check that your process is correct, and you must also be careful in expanding polynomials, because there's a lot of errors that you can commit when expanding a polynomial. So the final answer for this polynomial will be this one. So you can double check it using your calculator. So our next problem, 2x squared plus y squared, or quantity 2x squared plus y squared, quantity raised to 9. So very big value of exponent. So remember that number of terms that you will get is 9 plus 1. So we'll have here 10 terms. So imagine 10 terms. And that's why how binomial theorem is important, because what if the exponent will be higher than this? How can you get, or how can you expand the polynomial? So again, repeat the process. The first term would be the first term in the polynomial raised by the original exponent times the second polynomial, which is raised to 0, because it will increase, as what we have said. The second term of a polynomial will increase by 1 by term to term. So that's the first term. And then the second term is the exponent of the first term, which is 9, times the first term of the polynomial raised to 8, because it will decrease by 1. Then next is the second term. So we multiply this by the second term raised to 1, because it will increase by 1. So the next term, which is the third term, we have to multiply 9 times 8, multiply the exponent of the first term of this polynomial to this number, which is 9 times 8, that is equal to 72. Then we have to divide it by the exponent of the second term plus 1. So we have to divide it by 1 plus 1, so it is 2. So we have here 36. Then repeat the process until you get this term. You get this form, the form of this term. So this will be the last term. So you will continue the process, yeah, until you will be, or you will get this term. So again, we will have 10 terms here, since it is said that, as I have mentioned, the number of terms will be determined by the exponent plus 1. So we have here 10 terms. So you can count that, or we can count these terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can assure that this equation, or these terms, or our answer is correct. So the final answer for this equation, or for this polynomial, is this one. So again, you can double check it again, and please be careful, because here in this problem we have exponents of the first term and the second term. So you know that in algebra, if we have this kind of exponents, we multiply these two exponents. That's why we have here x raised to 18, and so on. So you can double check it if you want. So this is the final answer for this equation. Oh. So now try to solve this problem number 3, and this is the answer of that, and number 4, and this is the answer for that.